One of the most powerful features in Signal is the use of multiple frame states to set up a number of different sets of output pulses for use during an experiment and switch between these outputs during sampling. As an example, you could set up one state that generates a single stimulation pulse on a DAC output, another state that has two stimulation pulses separated by 20 milliseconds, and a third state containing a pulse train consisting of 10 pulses at 50 Hz. These states can be controlled manually, or Signal can switch between these outputs randomly or in a preset order during sampling. This is called Dynamic Outputs mode and is the most useful and general purpose way of using multiple states during sampling. Every sampled frame stores the state number that was used for that particular sweep. This allows analysis of responses to a particular set or combination of stimulus outputs. Multiple states are enabled by selecting the Multiple Frame States checkbox in the General tab of the sampling configuration. A States tab is then added to the configuration where state settings and sequencing can be defined. Dynamic Outputs mode is used to set multiple pulse outputs for use during an experiment. The other variations, static outputs and external digital, are only useful in special circumstances. The number of extra states field is used to set the number of output protocols you want to use, in addition to state 0, up to a maximum of 256. State 0, or basic 0, is always available as a default or idle sampling state. Repeats sets the number of times each state will be repeated during one cycle before moving on to the next. You can control states manually, or Signal can switch between states in numeric, random, or semi-random order during an experiment, and even run multiple user-defined protocols to control the state sequencing. We will take a closer look at user-defined protocols in a later tutorial. So, for this introduction, I will select random ordering. Other options set whether the states should start cycling automatically when sampling starts. The cycles before idle field can be used to set a limit on the number of cycles before returning to state 0 to idle. 0 sets no limit. Turn on writing to disk with cycling is selected by default. Individual repeats can be used to set up a different number of repeats for each individual state. This overrides the main repeats field in the dialog, which applies to all states. The pulse outputs that you want to generate during the different states are set up in the Pulses configuration dialog, which is found in the Outputs tab of the sampling configuration. Here you set the outputs that you want to use and the scaling and units for DAC outputs. For this example, I am only using DAC 0 with default scaling. Click Configure Pulses to set up outputs. The state to edit is selected from the drop-down list at the top of the dialog. And pulses are added by clicking and dragging pulses from the palette to the output tracks in the graphical display. Settings for pulses can be edited when the pulse is selected in the graphical window. Here we will set up our single pulse in state 1 with a size of 5 volts and a length of 10 milliseconds. Use the pulse train icon to set up our double pulse in state 2 with the same settings. And use another pulse train for our 50 Hz pulse train in state 3. When sampling with multiple states, Signal provides a states control toolbar to display the current state and allow manual or automated control of the state sequencing during the experiment. You can set your own labels for the toolbar buttons by editing the label field for each state. Clicking OK and then Run Now opens our data file and sets up our states control toolbar. We can start sampling and control the states manually, or use the cycle button, which hands control over to Signal and uses the ordering method we defined in the sampling configuration. I hope you have found this introduction to multiple states useful. In future tutorials, we will look at setting up multiple states for controlling MagStim devices.